All right, welcome to Math 10 A&W. This is Mr. Sandhu, and we are on page 28 of your Mathworks 10 workbook in chapter 1.2. This is example number 2. So let me read. Often unit price is used to compare costs. A 48-ounce can of tomatoes costs $2.99. An 18-ounce can cost $1.19. Which is a better buy? So you guys have done this kind of stuff before in your real life, and we're just going to use the skills that we've already been using and take it one step further. We're essentially going to calculate the unit cost of each one of these scenarios, each one of these purchases, and see which one has the lower unit price. All right? So what we will do is, you know this thing, I bump it and it does this. You guys want to throw me the page number there so I can get back? 32?
What?
You sure? There it is, 28. 28, there we go, okay. So, here we go. I'm going to take a look at what we have for information. I've got a 48-ounce can, costs $2.99, and an 18-ounce can costs $1.19. So, we want to know what the cost per ounce is. So remember I said yesterday that before you tackle one of these questions, you want to understand what the output's going to be. Are we looking for cost per ounce, or are we looking for number of ounces for a given cost? I say it's this one here. We want to know a certain cost per ounce. So make sure cost is on top, ounce is on the bottom. So cost is $2.99. And ounces is 48. Compared to how much for 1 ounce? Now I heard in the back there that one of the students is saying, well, why don't we just take one and divide it by the other and you can find the unit cost? And that's true. The reason I set up a proportion is because when you get yourself into a situation where, and it happens a lot, where you either forget how to do something or you're not 100% sure whether to, divide the $2.99 by the 48 or divide the 48 by the $2.99. Kids sometimes do get a little bit confused about which one to do, and then they just randomly do one. If you do a proportion, it works every single time because you're literally taking the words and putting it into a proportion that you're so comfortable with using. And so it just means that you're going to divide the right thing by the right thing and multiply the right thing by the right thing. It just makes sure that it works. That's the reason I keep falling back to proportion. So we've set it up. $2.99 for 48 is how many dollars for 1 ounce, and cross multiplying and dividing. So X is going to be $2.99 times the 1, which I won't show, divided by the 48. So that tells me that the $2.99 needs to be divided by 48 instead of the other way around, which means that X is all right, this is not working. $2.99 divided by 48. There you go. So 0.62. 0.062, which is equal to essentially 6 cents per ounce. Okay? So that's 6 cents an ounce, also expressed with 6 cents per ounce, or 6 cents per ounce. All right, let's do the second one and compare at the end which one of these is a better deal. So we have ounces on top and, dollars on top, ounces on the bottom. So $1.19 for 18 ounces is equivalent to how much money for 1 ounce. And cross multiply and divide, and you get you get 1.19 times 1, which I won't show, divided by the 18, which means that your value is all right. It's pretty close. So we've got 0.066, which means $0.07 per ounce, or 7 cents per ounce. So by a small margin, the one that is the better deal is the lower one. It's cheaper to buy the first one. So $2.99 for a 48-ounce can is cheaper. And that makes sense because in the real world, typically when you buy a bigger quantity, you get a better price, right? So that's how you do this. It's essentially everything we learned yesterday, except you're doing it twice and looking for which one's the better purchase. Thanks a lot.